In the wintertime, we feel cold because our body is losing heat to the surrounding. In order to keep us warm, we will typically wear more clothes to insulate ourselves. But do you know how to quantify the amount of insulation of a material? The driving force for heat conduction is temperature difference. In the case of our body, for example, we will typically lose heat to the surrounding because our skin temperature is around 32 to 33 degrees Celsius, which is higher than the surrounding temperature. And the larger the temperature difference, the colder we feel. Obviously, we know that we feel warmer if we wear more layers of clothes, so thermal conduction is inversely proportional to how much distance the heat needs to travel. On the other hand, heat conduction also depends on what type of clothes we wear. For example, a cotton shirt will feel colder than a down jacket, even if they have the same thickness, and that is because the thermal conductivity of the down jacket is smaller than that of cotton. In fact, the heat flux from our body, which is the power loss per unit area, is given by this equation. We can see that more heat is lost if either the temperature difference is larger, heat transfer distance is smaller, or the thermal conductivity is larger. Very often, people define a term called R value to combine the two materials parameters together, where R value is the length divided by thermal conductivity. So the equation for heat conduction per unit area is given by this. The larger the R value, the more insulating the material is, and the smaller is the heat loss. So you may ask, when is R value used? A typical place to find R value is in hardware stores, where they sell insulating sheets for home installations. Similarly, our house loses a lot of heat to the outside during the wintertime, so a better insulation, that is, a larger R value, can decrease the amount of energy loss, reduce the use of electricity for heating devices, and also reduce your electricity bill. Let us take a look at these two insulation materials here. We can see that the material to the right has an R value of 1.5, whereas the one on the left has an R value of 2.2. So by looking at it, the one on the left is more insulating. Let us see why. If you pay detailed attention to the package, it also gives you the thickness and thermal conductivity of the materials. For the left one, thickness is 100 mm, which is 0.1 meter, and the thermal conductivity is 45, which means 0.045 watt per meter degree Celsius. So R value is 0.1 divided by 0.045, which is 2.2. The one on the right has a thickness of 75 mm and a thermal conductivity of 50, and therefore correspond to an R value of 1.5. As we see, the one on the left is thicker and also has lower thermal conductivity, so R value is larger. Now we know how the amount of insulation is defined, we can easily calculate how much heat is conducted through a wall, for example. What we need to do is just take the temperature difference between inside and outside and divide it by the R value and multiply by the area of the wall. Take, for example, a wall of size of 2.5 meters by 10 meters, and the indoor and outdoor temperature difference is 10 degrees Celsius. The heat flux through the wall with an R value of 2.2 on the left is therefore 4.5 watt per meter square, and the total amount of heat loss through the wall is 112.5 watt. The corresponding heat loss through the wall with an R value of 1.5 on the right is 166.7 watt. We see that the heat loss is higher for the insulation materials on the right. One thing to note is that R values depends on the country you are in. In the US, the R value is different from that in the rest of the world. That is because in the US, R value is in imperial unit, whereas other places uses SI unit. For conversion, R value in the US is 5.68 times larger than the metric R value. I hope you have gained a better understanding of R value and thermal insulation from this video. Stay warm in the winter. Bye bye.